Hi and good morning everyone. Okay, so my name is Danny and here's my colleague Isabel. We are so happy to be here for the micro teaching session. So,
That's right, we are focusing on a topic called reaction mechanism. Our goal is to move beyond what happened in a reaction and discover how it actually happened. Before we start, let me ask a quick question. Has anyone ever heard about reaction mechanism before? Okay, don't worry. Today you will learn about it and I believe that you guys will understand about this topic easily.
okay, so before we start our session, we're going to through the objective. Okay, so at the end of the session, everyone should be able to first define the reaction mechanism and its elementary step, and the second one, everyone might identify and explain the role of reactive mechanism.
Okay, the third objective is everyone will able to deduce the overall red law from a proposed mechanism using a red limiting step approximation. And lastly, everyone will able to analyze the effect of catalyst and temperature on the reaction pathway.
Okay, now that our objective is clear, so we're going to start the session. First, let's go to the basic. I believe that everyone has studied and heard before about the stoichiometry. That's things that we use and show us how to write a balanced equation like this.
Alright, but how exactly does this transformation happen?
Yes, good question. That's the main things that we're going to learn in the class today. While the overall reaction just show us the starting and the end of the reaction, but the reaction mechanism is the series of the elementary steps that bridge the gap. This step often involve temporary species that we call reactive intermediates. So, I believe everyone here questioning what is intermediate, right? Okay, so what is intermediate, Belle?
That's a good question. Intermediates are species that are produced and in an earlier step and then consumed in a later step. They are often unstable, like radical H and Br.
Oh, I think that's right, Belle. And now, the things that we need to know is each individual step is classified by its molecularity, which are the number of latent particles involved in that single steps. We classify them as first, unimolecular, second, bimolecular, and third is thermolecular.
Understanding the mechanism allows us to write the correct overall red law, especially when a reaction involves complex sequences that are consecutive, parallel, or reversible. But here is the challenge. When multiple steps are involved, which one are dedicated to the overall speed?
Okay, to answer that, we rely on approximation like the rate limiting step approximation and the steady state approximation theory to demonstrate this powerful problem-solving method and give you a work example of how to derive the rate law of a mechanism. So, I'd like to hand the floor over to our third presenter, which is Hanif, to start the question 1.
Alright everyone, for this question, the first step that we need to know is to identify the intermediates. Remember that intermediates is the one that's been produced but never be the end product. Okay, the intermediate here, Cl produce. This one is produced and then that's not the end product. So we highlight that Cl is one of the intermediates. Okay, NOCl produce and use and not the end product. Okay, after we get to identify the intermediates, first intermediate, the second step step is, I call it as the rate determining step. Okay, for the rate determining step, we need to identify which one of this is actually the rare species. Okay, for me, this one is the rare species, and this one is also the rare species. Okay, so we got two rare species, but I think I do use it. Let's try use with this one. So the question asks us to find the order of duration, right? Okay. From this, we can clarify. Okay, this one is the rate of consumption. So we use this for the rate determining step. Okay. Right. So we got the rate determining step. After that, we see at our rate law. This one, CL and NO intermediates exist, right? This one, CL. CL is the intermediates. So from this, we get to go to the next step, which is steady state approximation theory. So we can make the steady. Okay, how do we write? So rate of consumption of CL is equal to the rate of production of CL. Like this lah. Okay, so we need to find that where's the CL for the equation 1, equation 2 and equation 3. All of it get the CL as the product or reactants. Okay, so how so we got this equation for the first one. No, this is the first equation. Okay, so from this one, we need to SSAT. The function of SSAT is to actually eliminate the intermediates lah. We don't want any intermediates in our equation. Okay, so what we can do? Take the first one and factorize first. So we need to make sure that our CL is actually the main. So we need to actually, okay, until here. We start until here. So what we can do is, because we start until here for the second equation, so in our second equation we got another intermediates, right?
Yeah.
So we need to find the SSAT for NOCL. Okay, so everyone already write all of this?
Yeah.
Okay, I need to continue, so yeah, I need to erase all of it. Let me do SSAT for NOCL. Okay, NOCL exists at the second equation and the third equation, right? Okay, so the first one, this is the SSAT. Okay, so what we can do, we need to make the NOCL in front. Okay, the first one, what we can do is, we can actually, here we can actually cancel the CL, right? So okay, now we already get our NOCL. Okay, for this one, I call it as equation 3. We need to substitute this one into the second equation first. Okay, so we need to bring all of this into here. Okay, so this is our NOCL. from this we can settle that K3 can be cancelled. Okay, so K2 and O, K2 and O, so 2 K2 and O, right, Belle? Okay, so sorry for the 2. Yeah, we got this is actually our fourth equation for CF. Okay, from this, remember our first equation? We go back to our first equation. From this, substitute 4 into that intermediates. Okay, so I will show you how do we substitute that. So what we can do, we are almost there. What we can do is, we can actually cancel this one, and also we can actually cancel this one, right? So the final answer might be, this is our final answer, but not yet. The final answer, we should clarify first that, okay, consider that K is actually equal to K1. So this is our final answer. But the question asks us to find the order of the reaction, right? So we need to deduce that the order of reaction is the first order.
So hi guys, so now I'll be explaining for the further question. As you see, what is the difference between the previous question and here is, we can see a reversible equation. So the key point when you see reversible equation is, break them into two equations, which are H plus BR minus forms HBR. Another equation, HBR produces H plus and BR minus. So in total, now you can see that you have 4 equations here. So now for question A, they ask us to identify intermediates, products, reactants and catalysts. So as you read the head of the question, they have already mentioned that the hydrogen peroxide is in acidic solution have been break down into bromide ion. So obviously we can know that our catalyst will be Br minus. Okay, so we have find out our catalyst. Now we go for our intermediates. So as we know, intermediates form when they are produced and also used again, but doesn't form at the final product. So when we look at we have our HBR. HBR is produced at the first step, then it is consumed by but it is not formed at our equation set. Then we can know that HOBR is also our intermediate. HOBR. Next, we can identify our product. As you see, we can use hydrogen peroxide as our product. As from the beginning, it is being used. It is being used as our reactant, as our product. Lastly, the balance two product we have are water and oxygen as our reactant. Sorry for just for some confusion. Product will be H2O2 and O2. Meanwhile, our reactant will be H2O2. So that's all from me for question A.
Okay, so for part B, we're going to find the rate. As the question given, rate will be directly proportional to the bromine added to the reaction. So firstly, we need to identify the rare species to form the rate equation. So what is the rare species you think?
O2.
O2, yes, that's correct. So So we write it. K3 Okay, so after we write the equation, the reaction for the equation, and then we will proceed using the SSAT method. So for SSAT, we will use intermediate. So by applying SSAT, so by using SSAT method, we know that the formation of rate of HOBR will same with the consumption of HOBR. So we proceed to substitute everything inside the equation. So for HOBR, you notice that HOBR appear here as a product and appear here as a reactant. So we know that for positive HOBR, which is the rate of formation of HOBR, is the product side. So we're using the second equation. And then for the consumption side, you know that it is a reactant. So we use the third equation. Okay, so the equation is formed, and then we will proceed to let the concentration of HOBR be on our left hand side, and other thing we will move to the right hand side. So when we continue with the step, we notice that H2O2 appear in the denominator and the numerator side. So that means we can cancel out each other at the denominator and the numerator. So the answer will become K2 over K3 and then HBr. Okay, so this will be our first equation. From the first equation, we notice that HBr still intermediate, which is the intermediate still inside our equation. So we need to proceed with another SSAT to find out what is the concentration of HBr. Okay, so the same equation like just now from HOBr, but this time is for HBr. So we proceed the same step. We find out the HBr place. HBr in the reactant and one more HBr in the denominator. In the product side. And then one more HBr in the reversible equation. So we substitute everything inside the equation now. Okay, so we will get the equation like this. Then we can proceed with the equation just now. So, sorry, a mistake just now. So, if we want to make our step become easier to solve the question, so we notice that actually we can compare the equation, like for the first equation add with the two equation, or the first equation minus with two equations, so we can get another equation to solve. So we proceed with the easiest method which is add. And so we using this, the first equation, we will add with the second equation. Okay, so we notice that on our left hand side we got K3 H2O2 HOBr. Here also K3 H2O2 HOBr. And then our right hand side K2 H2O2 HBr. With same with this. So I want to ask your opinion. Do you think that this is plus or minus?
Minus.
Minus, right? Yes, correct. So if we do minus, so the equation we will get is K1 H plus Br minus will equals to K negative 1 HBR. Okay, so the equation become very short. So for now, we know that intermediate HOBR and HBR. So we can make HBR equals to something. We will get the answer HBR equals to this. So this is our third equation. Okay, so we look at the first and third equation. We got a HBR here. We notice that we can substitute into the equation. So that after we substitute, it will become like this. So from here, again, our intermediate HOBR, HBR. So after we substitute our third equation into the first equation, we will get this, and then from here, we can find out what is the HOBR. So So this will become our answer for HOBR. Since H2O2 and H2O2, both sides, left hand side and right hand side also have, we can cancel each other. So no more for H2O2. So this will become our HOBR. Okay, so after we obtain both intermediate HOBR and HBR, we back to our equation, we substitute. Okay, so after we substitute, we simplify it. K3 and K3 we can cancel out. So left is K1, K2 over K, negative 1. H plus. And then H plus. Minus 6. And H2O2. So we go back to the question just now. Question asked for the rate will be directly proportional only to BR minus. So that means we need to proceed with these, all the things will become include to the K, and then only left BR minus over here. And we need to denote that K is equals to K1, K2, K negative 1, H plus, and H2O2. We stop here, and this will become our final answer for this question.
Alright.
Yes, understand?
Yes.
So that's all from me. Thank you.